Okay, tonight I want to talk a little bit about relays. Now, I'm not an expert on this. In fact, I really don't know as much as I'd like to know about them, but I can use them fairly efficiently. And that means a lot to me because up to about 2 or 3 months ago, I absolutely had no idea how any of these devices on my desk worked, except for this one. Now, a relay is a switch, just like this, on and off. Okay? The difference being is that a relay can be triggered by a relatively low voltage to control a much higher voltage. If you look at the side here, give you the specifications for this. It can operate 30 amps, 120 to 240 volts, or it can operate a 2 horsepower motor at 20 amps or 600 volts. So I could do that with a switch, but with a switch you run a risk of it welding shut or there being less control. Like if I wanted to put a sensor, hook up a timer or a temperature controller to my circuit, I can't do that with just a switch. A switch is on or it's off. With a relay, I can quickly turn something on and quickly turn something off. And let me demonstrate this, okay? Let's see, I don't think I can zoom in on this particular one. It doesn't want to zoom in, but that's okay. So, wake back up. Wake up, it's okay. There we go. Alright, so, let me demonstrate. This is a higher voltage relay right here. Now, the benefit is that I could operate this relay. I believe I can operate this one as low as 3 volts, but it's recommended at 24 volts. See that right? It actually tells you what the coil operates at right there. But I should be able to operate it at a very low voltage as well, fairly easily. So here's a 9-volt battery, and you can just watch it make its connection. There we go. That's it. So the benefit of that is that I can quickly make or break a connection. So as fast as that connection is made. So if I had a light sensor or a temperature sensor or any kind of microcontroller collecting an input, I can control a relatively high voltage device. Now, there's a couple of different types of relays. Obviously, there's this very large one here, which connects very, very quickly. I'm sure there's some specifications for that are really important for some people to know, but luckily for me, it's not as important. Now, we have solid-state relays like this, where you apply a voltage here. Wake up, there we go. Where you apply a voltage here between 3 and 32 volts of direct current and connect the switch here. And these, I happen to know, actually have very fast connection time. And one of the things I like about these is they don't click. They actually have a visual. Oops, it might help if you have your polarity right, you moron. They have a visual indicator that they're on, and it is a little LED in there. So it's really nice. Unfortunately, these get hot, and so you have to put them on a heat sink and have some airflow going, which is not really a big deal. I just learned about these. I never knew anything about a solid-state relay until I wrote up the schematic you see underneath here. This is for my coffee roaster, and the connections control different things with the temperature controller, like this guy right here, except one that works, controls the heating elements. And so I had to learn of a way that my controller could actually turn on and off my heating element. And so I discovered solid-state relays. Now I have 2 different types here. This one is 25 amps, and this one is 40 amps. And they work very well. I actually have 2 in the coffee roasters controllers right now. Alright, and now let's talk about these little guys. Now these guys came out of a machine that I took apart quite some time ago, and they're really kind of cool. They tell you that they can operate 250 volts, taking up to 7 amps. I'm sorry. And I don't know the coil. I'm sure the coil voltage is probably written right there on that blue writing. But these guys are pretty neat because you can permanently install this bottom portion here and remove the actual relay. So you can install this where you want it and operate the relay. Now the relay is pretty neat, and I can tell you the voltage. Should be able to tell you the voltage now. It operates on up to 30 volts. So if you look inside of there, you can see it is almost identical. Focus, you can do it. There we go. To the big one. It's just small. So, and then of course you have relays like this, which you will see in your car, and it works virtually the same way. Now, how does a relay work? Well, I can't speak for these guys because I've never taken one apart, and I really don't know yet. That's something that I'll explore soon. But I do know about these. On each relay is a coil, an electromagnet. And when you apply your lower voltage to the electromagnet, it pulls down the metal piece to make the connection very quickly. And if you look real carefully, you see that spring? That spring allows there to be flex, so it smacks down and really makes a good solid connection. And on it, there are connectors. Now, there's this connector, this lug, which goes to this plate right here. And of course, this plate goes over to here to this lug and forms the switch. You could trigger it by putting a finger on it and hitting it back and forth like that. Now, I wouldn't recommend that because there can be up to 240 volts, up to 600 volts, 600 volts on this thing at one time. So it works just like a switch, but I can control even such a high voltage with a small timer or temperature controller. Alright, so let's talk about another type of relay. Now, believe it or not, this guy is a relay. Now, it's designed so that you wire it up according to the schematic here, and the schematic will allow you to do this nice little analog numbers here, and you'll see a time readout up here. It allows you to control motors and well, just about anything through a timer switch, and it is a relay. If you look really carefully right here, you can see on number 8 and number 9 there is the schematic for the switch, and you just follow that down here and you would have where you hook up at. So that's pretty cool, and that's the main reason that I decided to learn how to operate these relays. I also use a relay in my electronic station that I made for my soldering iron and all of that. The relay turns on my power supply so that I can have direct current power supply right at my fingertips, and it goes from 10 volts to 16 volts. And why do you not want to focus? Boy, that glare. But I really like this style here because it has 4 different connections. If you look inside, you can see that there's 1 and 2, and of course those connect to the other side, 1 and 2. And so you can connect up to 4 things. Sorry, 2 things, and have this thing control them. So this is the coil power here and here, which is very, very low voltage. I think my switch out in the shop operates at 2 volts. And then this is your source here and here. And then these are the connectors that can go up to your source. And if you look inside, you can tell there's a white wire there and a white wire there, that the sources are independent. So this source is for these 2 items, and there's a normally on and then a off over here. So whenever you trigger this relay, excuse me, why do you not want to focus? Anyways, when you trigger the relay, this one comes on here, and when you turn it off, this one comes on. So you can use it to turn on a load and turn off and turn on something else. So if your load is an indicator light, so that you know that whatever this load is on, your motor, your fan, your whatever, then this can be the opposite color light, so this could be green and this could be red, to let you know that whatever else you have operating on this particular relay is now on. So you can control up to 4 individual devices off of this one relay, and it's really great for me because I am not good with microcontrollers. I need quite a bit more practice to become proficient at it. Now, I'm going to pop the top off one of these, and it's not that hard, but I have to be careful because I do want to reuse these. I don't want to have to buy any, and these came at a great price, also known as nothing at all, and I don't want to mess them up because they've already come in useful. So let's see if I can get this apart. Nope, and I just heard it click back into place again. Alright, so this one, and this one. And damn it, why you do this to me? So anyways, I'm probably not going to be able to get this guy apart. Well, anyways, I don't need to take it apart because I've got this big one sitting here. The big one works the exact same way as the little ones. Obviously there's the coil, which I've already showed you how it operates, and the switch. These are just a miniaturized version that can handle a lot less current. Now, what about my solid-state relays? Well, the solid-state relays have a much faster reaction time. Now, in my application, there's not a whole lot of need for that, except it will allow me to have more control over my heating elements. So, whenever my temperature controller, my PID, detects that the temperature is 480 degrees, 500 degrees, whatever I want it to set at, then it will send a signal from number 4 and number 5, which are these two pinouts, to the relay, and you have to pay attention to polarity again, and turn this switch on or off. And it makes no audible click, it's very quiet, and I'll demonstrate that again, you can't hear it. No noise whatsoever. Whereas even these ones make a slightly audible click. And I don't know if you can hear that. Let me get my big head down in a way so you can get the microphone close by. So even these ones make an audible click. So there's an actual moving part inside. Versus these, where I don't believe there's a moving part. I believe it is it's solid state, so there's no moving parts in these. Now the benefit of that is that I don't have to worry about wear and tear on these. They're likely to be able to operate for thousands upon thousands of operations. So on, off, over and over and over again without any problem whatsoever. Whereas these, if you look very carefully, there is a pad here. It's a copper pad, and I can pry it apart just a little bit there. The copper pad will actually corrode over time, and you can see the corrosion right there. I've cleaned it pretty well, but the corrosion is still evident. And that corrosion will make your switch less and less efficient as time goes on, which means that if you're operating something that has a high load, like a heating element or a bigger motor, that this type of relay will wear out very, very quickly. Whereas this type of relay, which is good up to 40 amps of draw, and 300 volts, 380 volts, this one should stay operational for a much, much longer period of time. So, in your next project, if you are wishing to control a higher voltage load, such as a motor or a heating element or even a light, then you might want to consider using relays in your next project. That's it. Good night.